Everyone, Mr. Wiseman speaking, and today we're going to do a recap of laws of exponents. Now, this is your this what your paper one consists of. It consists of exponents and surds, equation and inequalities, function and graph, and your paper two consists of analytical geometry, trigonometry, and Euclidean geometry. Now, I highly advise that you try to get this type of calculator because throughout our videos we'll be showing you tricks that is inside the calculator that can help you achieve the mark that you are looking for. Now, here, this is our laws of exponents. Now, the first thing you have to understand, what is an exponent? An exponent tells you how many time the base will be multiplied by itself. If we have something like 2 squared, therefore this is telling us that we're going to say 2 times 2. Now, here, the laws of exponents, it begins as when the bases are the same, you add the exponents. How? When you have the same base of a and a, therefore the exponents, you add them. That's why you see we have the result of a raised to the power of m plus n. An example is here when you have 2 times a 2 cubed times 2 to the power of 4 is the same as 3 plus 4 equals to 2 to the power of 7, which our final answer gives us an answer of 128. Now, the second law tells us when you raise a power to a power, then therefore you have to multiply both the powers together. You can see here we have 2 raised to the power of 3 raised to the power of 4, which gives us an answer of 2 raised to the power of 3 times 4, which gives us 12, and then therefore we have 496 as our final answer. Now, the third one tells us when the bases are not the same. Okay, when the bases are not the same and it's being raised to an exponent, you take that exponent and raise it to both the variables. You raise it to both the terms. An example can be here as we have 20. Now, this 20 here, we can separate it as 2 times 10. We can separate it as 2 times 10. You're going to take the cube, you're going to raise it with the 2. You take the cube, you raise it with the 10. Therefore, you can see we have an answer of 8 times 1,000, which our final answer is 1,000. Now, when division is happening, okay, when division is happening and then it's being raised, what you're going to do, you're going to take that exponent, raise it to the power of a, take the exponent and raise it to the power of b. Therefore, our final answer is a to the power of n all over b to the power of n. And this is our example here. As you can see, we have 2 over 5, which equals to 2 raised to the power of 3, 5 raised to the power of 3, which gives us an answer of 8 over 125. Now, laws of exponents tells us that when the bases are the same and division is happening, when the bases are the same and division is happening, you minus the exponent. So you can see we have 2 to the power of 5 all over 2 to the power of 3, which gives us an answer of 2 to the power of 5 minus 3, which eventually becomes 2 to the power of 4, a 2 to the power of 2, which our final answer is just 4. Now, this one here for the last one, okay, for the last one, you do this when the exponent of the numerator, the exponent of the denominator is higher than the exponent of the numerator. So when we have something like that, therefore we're going to have something like 1 over n minus n, 2 to the power of. Now, this one here, we only do this for this. It's when our base, when our base on the numerator, okay, when our base on the denominator is greater than it's greater than the exponent on the numerator. Therefore, an example can be we have 2 to the power of 3 all over 2 to the power of 5. That's why you see we're going to put 1 all over 2 to the power of 5 minus 3. So when the numerator is greater than when the denominator is greater than the numerator, what you do, you bring the exponent of the numerator down, and you put it all over 1. Okay, now let's go and do one example to see how we're going to do it. Now here you can see this one here. What you using board mains, okay, we're going to leave the 5 first outside because board mains tells us bracket off. Let's off there, it deals with the exponents. Now since we're raising a power to a power, we're going to have something like m2pt. Okay, now once we're done with that, we can multiply the 5. Okay, so m2pt. Now multiply by the 2, we leave it outside. We have something like m3pt. Okay, which will multiply by 2m3pt. Okay, now once we're done with that, we can multiply the 5 with the 2, which gives us 10. And then since our bases are the same and our bases are the same, therefore we can add our exponents, which becomes now m5pt. Now the rest I'll leave for y'all to do. Whatever you don't understand, you can comment you can comment in the video. Then we'll be attending to you. Now you can see when you have this type of stuff, okay, knowing our exponents, laws of exponents help us now to solve this type of stuff, because we can see this before it became that it was like this. We're going to say 3m multiplied by 3 to the power of 1. Now once we get something like this, okay, and we can see that we have a subtraction, we can pull out something that is common. So the thing that is common from both sides is 3 to the power of m. We open our brackets. Now once we pull out that, we're going to leave with 1 minus 3 to the power of 1. Okay, we close our brackets all over. Here also we can see that since we have a subtraction, we can pull out something that is common, which is 3 to the power of m, open brackets, 4 minus 1. Okay, these two, they cancel each other, because in the only way we can cancel is if multiplication is happening. If multiplication is not happening, we cannot cancel each other. And then here we have something like negative 2, because 1 minus 3 is negative 2 all over 3. This is our final answer. Thank you. This is all for today. Now that you have the knowledge that you require, it's time to shock your teacher. See you in our next video. Thank you.